All right, we are live. Hey, everyone. Thank you so much for joining me today in the Hudi Community Sync. We'll give it a couple more minutes and then we can get started with our schedule. Let us know where you're joining in from today. I'm based out of Toronto and I'm really excited about the presentation today and sharing with the community what the organization has been doing with Hudi. All right, we are a minute over our scheduled time. So, once again, thanks everyone for joining us today for the Hoodie Community Sync. If you're new here, the Community Sync allows community users and developers to meet, interact, and exchange ideas on Apache Hoodie and how it is implemented in various organizations for their data lake and data lakehouse needs. So, I'm your host, Dipankar. I'm a staff developer advocate at OneHouse.ai and run the community initiatives here at Hoodie. And today we have yet another interesting presentation from the Halodoc's data platform team. So if you're unaware of Halodoc is a digital health ecosystem, and it aims to simplify the access to healthcare by connecting millions of patients with licensed doctors, insurance, labs, and pharmacies across Indonesia. And during this presentation, our speakers, whom I will introduce in a moment, will share Halodoc's journey and how they evolved their architecture to drive significant improvements in performance and at the same time lower S3 cost using Apache Hudi. So before we go to our presentation, let's give some community numbers stats. So in the last month, we have had around 72 PRs, and a lot has been brewing on the Hudi project side. We have had 22 developers who contributed to these PRs from various organizations. We also closed 4 issues during this time, and there are also new PRs being worked on. So really some good momentum overall in the project. In terms of the community growth numbers, we have over 4,757 plus Slack users today. Slack is a great place for Hudi users to bring up any discussions, issues while implementing Hudi, knowledge guides, and there are PMCs to chat as well. So I'll share a link in the next slide, and there is a QR code for you to join as well. But really good place to be in the community. On the GitHub side, we have around 5,800 plus stars, so some numbers over there as well. And if you haven't already given us a follow on LinkedIn and the socials like Twitter and X, please do so. We post all the latest stuff that's happening in the community over there. And also, if you like the project overall, have been using it in your organization, feel free to give us a GitHub star. And here's the QR code for you to scan the for the Slack community joining. And with that, we will welcome our speaker, Isra. Um, Hi, Isra. Welcome to the Hoodie Community Sync. And
Yeah.
thank you so much for taking the time. I know it's a little bit late today, from the Indonesian time perspective, but really appreciate you taking the time.
Okay. Thank you, Dipankar.
All right.
Yeah. We'll.
I'll get the slides up for you. There we go. Over to you.
Okay.
Yeah.
Yeah. Thank you, Dipankar. I'm data engineer at Halodoc. So yeah, I'm excited to present our journey at Halodoc and our transformation on our Apache Hudi. So before we begin, I would like to, like Dipankar introduced previously, Halodoc is a healthcare platform technology. By using Halodoc, people in Indonesia can get high quality healthcare services, including chat with licensed doctors, get others. Okay, so yeah, today this is our agenda. We will cover several key aspects on our lakehouse data processing architecture, we will deep dive into our significant technical decision where we migrate the data from MOR to COW table, and how we improve observability using metric collection, and how we use DynamoDB for Hudi multi-writer support. Okay, so data lakehouse processing architecture. So at first our data lakehouse journey begin in our architecture. So it's a collection of an unprocessed raw data where we collect data from the various data sources, including data from Amazon RDS, where we get it using DMS. And also we store the data in the CSV format, data from Google Sheet, and data from another data sources. From raw layer, EKS, where we have our PySpark code that using Hudi to process the data to more reliable the data that can be queried across data. Is also sit in our S3. And further, we transform the data based on our business logic, based on our business needed. We create our data model layer in Amazon Redshift. Here we are using Amazon EMR on EKS to execute the transformation based on we implement the business transformation here, and all of our process is orchestrated using Amazon MWA, and all the data in process layer, it's catalog in Glue data catalog. It's available in and discoverable in AWS Glue data catalog. I would like to discuss on our significant strategic decision where we choose to migrate the data from our Hudi table from MOR to COW. So when we initially adopt Hudi, we consider to use MOR table, merge on read table, because it's near real-time capabilities. So at first uh, we think that we will have more uh, near real-time use cases, but after our data platform mature, after several times, we observe several things. Our use case mostly batch oriented. So while MOR table, it provide another two views that allow us to query a near real-time data using underscore RO, read optimize, or real-time table. So this create compaction overhead. It means when we use MOR table, another additional process when we write the data to our Hudi table, it need to compact the data. So this is a we observe this is a somehow costly and resource intensive process. And also because MOR it create two views, it create two tables in Glue data catalog. And when our data consumer want to access the data, it create a naming confusion for them. Every time new data consumer want to access the data, we need to explain, or we need to route out to them to query the correct data. Okay, so from that observation, we reevaluate and we realize that copy on write was a much better fit for our use cases for our batch processing model. So with COW table, the data is written directly right to the Parquet file during the ingestion. So it eliminates the need for the compaction process. And also, additionally, we get a performance gain where since the data directly in Parquet format, it leverages the Spark native Parquet optimizations. The result after we switch from MOR to COW, yeah, we see processing efficiency where we observe the Spark step count on our data process is drastically reduced by 42.8%. So yeah, it translates directly into the faster processing times and it lower our resource utilization. Yeah, it's also impact in the cost our cost since the we observed that S3 API call is also reduced by 22.12%. Yeah, again, it's reduce the S3 cost also. So for our specific workload pattern at Halodoc, transitioning into a COW table is give us an efficiency and cost-effective lakehouse pipeline. So moving to the next, yeah, as we know, data is rarely static. It grows as it evolves as our business grows. So yeah, how we handle this using Apache Hudi at Halodoc. So the good news is Hudi itself has built-in support for the schema evolution. It seamlessly handle the column addition, column deletion, and it support many data type changes. However, we encounter a specific challenges in our use case where it related the glue data catalog changes. When we update the schema in glue, let's say we change the data type from, let's say in this example that we found is something in that involving decimal data type. Let's say we change the data type into integer to decimal for a specific table or increasing a decimal precision. So what happened is when we update the glue catalog schema, it only update the glue metadata. It not update the data itself where it sit in S3. So it create a problem when a new data write into that table, it will throw an error that the schema mismatch when writing, even when reading the data. So our solution is on top of the Hudi native support. We maintain a central control plan table for collecting the RDBMS schema. So what we do is we collect the table name and the schema name for the table that we migrate. And also on top of that, we create a custom schema comparison module. What it do is it will ensure the schema consistency across our data lakehouse pipeline. We also introduce the automate handling for most changes. Yeah, let's say uh, if there is a data type changes, our pipeline will alert us and some automate job handling process will be triggered. Yeah, so this is the flow, the data flow on how we handle the schema, how we use the schema comparison module. So what we do is we get the schema from the PySpark data frame from our raw data in our processing, and we compare it with the config table schema which we store in our control plane. And then we compare both schemas. If the both schema match, then our incremental process will continue. But if we found a schema different, we will trigger, it will automatically trigger a schema handling process, yeah, it including the new column addition or schema data type changes and so on. Okay, so next is yeah, managing the large data platform. It not only we are dealing with operational incremental data, right? So we sometimes we need access to the uh, Hudi service job. For example, in this one is to roll back, upgrade, or downgrade a Hudi table. So, but when we want to use a Hudi service like rollback, upgrade, or downgrade, we want to eliminate the manual process that usually we need to use a Hudi CLI or directly create a Spark submit job. We want to automate all of that. We want to automate the rollback, upgrade, and downgrade process, but we do not want to directly touch the Hudi CLI or Spark Submit every time we deal with the Hudi service. So what we do is we create an Airflow DAX, an Airflow DAX, which in background it will trigger the Hudi CLI or Spark Submit, yeah, based on the parameter that we pass. So yeah, the goal is we do not any data team can do the operate the Hudi service job without the need to accessing the Hudi CLI or submit job using a Spark submit. Yeah, this is our next, let's say, journey or transformation in our lakehouse. We collect all the metrics related our table. Yeah, it from the Hudi metrics, we collect the data. We also collect the data from the S3, uh, S3, and also we collect the data from the Apache Spark. What we collect is yeah, from the Hudi commit metadata. This is related the tables related metadata, right? So when we collect the metadata related the total record, total files, and duration from the Hudi itself, we also periodically scan the S3 files that correspond to that Hudi table. We get the row count, partition, and total files of that table. We also capture the metrics from the Spark. So yeah, we can get the we can see the Spark related job using Spark UI, but we need to store that. It's good to store that into the our storage, let's say Redshift or something where we can query it and we can reuse it for future use cases. In our use cases, to check the whether we are over or under provisioning resources, or we can also check the inefficient shuffling process that involved in our job. So yeah, after we collect all the metrics that we can collect, we create a dashboard using BI tools, and then uh, by using that dashboard, we can identify the over provision job. We can tune the executor memory and course of its job based on the data, and it also outcomes by reduce in spark retries and failure. Yeah. So uh, we have a scenario where multiple Spark job might need to write into the same Hudi table. Uh, so for example, is our daily or batch processing incremental jobs running. We also have a job to backfill or reprocess that Hudi table. So if these two process running uh, by at the same time, potential there is a potential that it run in the same time and it will create the data corruption or data inconsistency. Right? So to address this, we introduce the concurrency control mechanism that so basically we are utilizing the native Hudi for multi-writer support by using a DynamoDB option. Yeah, so after we there will be no two same process that writing the data into the same table. So it prevents the rest condition and it ensures the data integrity with multiple active writers. Yeah, that's the end of my presentation. So we have covered the high level, our legacy to COW, and so many others. So for more in-depth related technical implementation in this topic, I highly encourage you to check our engineering blog at blogs.halodocs.io. Thank you. Over to you.
Yeah, thank you so much, Isra, for taking the time once again. So really appreciate that, and of course, shout out to your blog as well. Like, I would highly encourage the viewers to, like, visit that. Really good, like, technical bits and pieces. So really good work around that as well. Um, I, I see a couple questions. Maybe I'll just pose it your way, and if we have anything else, we can take that as well. So one question was around, you said, like, the you guys changed from merge on read to copy on write. Is it because most of your use cases was around, you said batch? Are you also, like, do you also have streaming use cases, or are you considering MOR in the future?
Yeah. So our use cases now is mostly batch processing, or even if it's we have mini batch also, but we cannot say it's near real time, but it mini batch where we process the data at 30 minutes interval or mostly 1 hour interval. So maintaining MOR table for that small
Yeah,
use cases is cause several downside for us. So yeah, that's to answer the question. Yeah,
got it.
because our use cases is mostly batch processing. Our process is daily. We have a daily batch schedule processing only.
Got it. Thank you so much. Yeah. The next question I have is around your automated, like, the framework that you built around schema evolution. So the question is around, like, how do you ensure, like, what is the approach that you take to automate the service? Basically, I think they're asking whether, like, you have some kind of, like, error message that you see, or how do you basically tackle, okay, that looks like a good diagram to follow. Yeah. So maybe just some quick idea like around in general how you like automate that process. I think that would be great. Yeah.
Yeah, sure. So yeah, this is the comparison module that we built. Yeah, to if we found there is a schema changes between data frame we create in our when we write the data, we create the data frame, right? And then we compare the schema from that data frame with existing config table schema that we stored in our control plane. So if we found there is a, let's say, a new column introduced into the incoming data, right? So we will update the config table before we will update the config table. So for a future needed, right? Uh, I mean
Right.
for the next incoming process. And if there is a data type mismatch. For example, like we see the challenges here that involve specifically the decimal in glue data type. We need to recreate that glue schema. So we in our automate handling process, we will delete that glue table and recreate that glue table itself. So it automatically handled in our process.
Got it. Yeah, thank you so much once again for sharing that insight. Yeah. I think one last question that I have personally is around you talked about a little bit about the concurrency model and how you use the DynamoDB to kind of tackle the race condition and stuff. Do you have a lot of high contention job? Like, is it like multi-writer, like couple of multi-writers and that kind of environment at your use case?
Yeah, the multi-writers is only for the we have basically mostly two use cases where
Okay.
that multiple job might be need to handle. So one is the incremental job. Let's say we have a 30-minute interval job, but it run for sometimes for 5 minutes or 10 minutes. At the same times, we have a need to reprocess some failure event or some previous data that we see there is a mismatch
Right.
in our data. So accidentally, if that happen, there will be no, let's say the error is not visible,
Yeah.
and then the data is still consumed by our end user.
Sure.
So yeah, to avoid that specific use cases,
Got
we
it.
enable the DynamoDB multi-writer support.
Got it. Perfect. I think that was it. Once again, Isra, I really appreciate taking the time. I think it's pretty late at night, so and thank you so much for sharing with the community. I'm sure the community has learned a couple of things around this presentation, and for the viewers, thank you so much for joining us today. And we will have all of this material in our YouTube and all the slides and everything up as part of the particular link. And then we look forward to the next community sync. Thank you so much, Isra. Have a good night. Bye.
Yeah. Thank you.
All right.
Thank you. Bye.